Welcome to this presentation on pointers. Pointers are one of the topics that make C programmers worry the most. What we're going to learn in this lesson that a pointer is a memory address. Where it gets challenging is remembering when you're working with the memory address and when you're working with the value that's stored at that memory location. That's what we call dereferencing a pointer. We take the address, we go out to memory, and we find the value that's at that address. And so we're going to look at pointers in detail in this lesson. And then in a future lesson, we're going to look at character string operations using pointers. And that's when everything should come together for you. You'll start to understand that we start at a memory location. We know the type of value that's at that location. We can get it. If we increment the pointer, we're looking at the next value of the same type. And so we just get used to working with addresses and values that are stored in memory at that address. So let's go ahead and get started. So we've learned that a pointer is an address. It can be a pointer to a character string in memory. It can be a pointer to an integer value in memory, but it's just an address, a memory address. And so in this case, we're declaring a variable called value that's of type int, and we're giving it the value 1000. And so we want to know where is C storing that value in memory. And to do that, we can use the address operator, which is the ampersand. The ampersand will always return the address of the variable we specify. So in this case, we're saying, give me the address of the variable named value. To display it, we're going to use a format specifier, LU, for long unsigned. And so we're passing that address to printf, and it's going to display it. So let's go ahead and run this application. And sure enough, we get the address of the variable in RAM. Lots of memory depending on the operating system that you're running at, but we know that in this case, this is the address of the location where C has stored the variable value. Key points, the ampersand operator will always give us the address of a variable in memory. Let's look at another example. In this case, we're declaring two variables. One called value, we're giving it the value 1000. One called B, we're giving it the value 2. Our printf statement says the address of value in RAM is this location. We just did that. Then it's saying the size of value, the number of bytes that it takes to store the value, is this number of bytes. That means our next variable should start at the address of value plus the number of bytes. That will give us the next location in memory for our variable. And so we're going to display the value of B as well. And so we're using the ampersand operator to get the addresses. Let's run this and see what we see. And so we see that the address of value in RAM is the address given. The size of value is 4 bytes. That means the next value should start at about this location, and just look at the 32 as the ending location. And sure enough, the address of B in RAM is at that 32 location. So you can see how the C compiler is kind of storing variables in successive memory locations. So we said that a pointer is an address to something in RAM. We can declare a pointer variable. It's going to be a variable that stores an address. To declare a pointer variable, we specify the type of value we're going to be pointing to, followed by the asterisk in the variable name. So in this case, we're declaring a variable called value, and we're assigning it to value 1000. We're then declaring a pointer variable. You see the asterisk before the variable name. It's going to point to a value of type int. We're going to assign that pointer variable the address of value in memory. And so we use the ampersand operator to get the address of the variable value. We assign that to pointer, and pointer is a pointer variable, so it can store an address. To get to the value that's pointed to by a pointer, you use the asterisk again. So the variable name pointer contains an address. We want to know then the value that's at that memory address. And so to do that, we use asterisk pointer. So let's go ahead and run this program. What we should see is we assigned pointer the address of the variable A in memory, or of value. And value has the value 1000. So if that's what pointer is pointing to, we should see the value 1000. And sure enough, we do. Let's look at another example. In this case, we're doing the same thing. We're assigning a variable value, assigning it to value 1000. We're declaring a pointer to a value of type int called pointer. We're then assigning pointer the address of value, and we're saying change the value that's pointed to by pointer to 5000. And when we do that, it changes the value at that memory location to 5000. Well, that memory location is also the location of our variable a. And so we should see a's value change when we run this program. And sure enough, we do. The value pointed to by the pointer is 5000, and the value of a is now changed to 5000 as well. So using a pointer, we can get the value at a memory location. We can also change the value at a memory location. Let's take a look at one that uses a pointer to a floating point value. In this case, we declare a variable called pi, assigned at 3.14. Then now our pointer is a pointer to a value of type float in memory. We're assigning it the address of our variable pi. Nothing different than what we did before. We're just using floating point numbers this time. We're then just saying the value of pi is this, and we change the value of that memory location that's pointed to by pointer to give a different definition of the pi value, which is 22 divided by 7. And so we assign 22 divided by 7 to the memory location that's pointed to by pointer. And because that memory location corresponds to the variable pi, we should see the variable pi's value change. Let's run this program. And sure enough, we started out with pi being equal to 3.14. When we used the pointer to change the value at the memory location, that changed it to a more refined value of pi. So we use the ampersand operator to get the address. We use the asterisk operator to manipulate the value that's at that address. So we know that an array is a data structure that stores multiple values of the same type. Behind the scenes, the C compiler and C treat an array as an address. Let's take a look at what we've got going on in this first program. We're declaring an integer array as the values 1, 2, 3, 4, and 5. We can display the value of that array just by referencing the array name. And so our program says the address of array is at this location. Let's go ahead and display that value. And so we know when we pass an array to a function, it's got the starting address. It can get to each element of the array using that starting address. The first item will be at offset 0. The next one would be at the offset that's the size of the value it's storing. If it's an integer, 4 bytes more. If it's a double precision variable, 8 bytes more. And so we can start using the address to get to different values. So let's look at the second program. We're declaring two arrays. One's an integer array with values 1, 2, 3, 4, 5. The second is a character string array with the message hello world. And we're displaying the address of each one of those. Let's run the program. And so to reference the address that array is stored at, you just need to specify the array name. So how would we use the pointers to an array to actually do something? In this case, we're declaring a character string array called string. We're assigning it the character string hello world. And then we've got a function called showString. You see that the function is getting passed a parameter that says we're passing you a pointer to a character string. And within the function, we can use that pointer to loop through the characters of the string. And so we're going to loop as long as the character is not the null character that marks the end of the string. We're going to display the current character that's pointed to by the address, the first character in the string. We're going to display it, then we're going to increment the pointer and point to the next character in the string. And as long as it's not null, we're going to display it. And we're going to increment and go to the third character in the string. As long as it's null, we're going to display it. So we're going to loop through our string using pointers. Let's run this. And sure enough, we see it's looped through using pointers our message hello world. Let's do one more. And so again, we've got our showString function. Let's walk through this. Let's look at its parameters. It's saying, I'm getting a pointer, that's what the asterisk in front of string means, to a value of type char. We're passing to it the first location in our character string. So we can look at that character, display it, increment our pointer, we're looking at the second character string, display it, increment the pointer, we're looking at the third character in the string, and display it. And so again, we should see our hello world message. And we run the program, we do. So in the previous example, we looped through an array of characters, which is a common operation in C using pointers. In this case, we're going to create an array of type float with the values 1.1, 2.2, 3.3, 4.4, 5.5. We're then calling the function showArray, passing the address of that array and the number of elements it contains. Within the showArray function, we've declared our parameters as a pointer to a value of type float and the size. So using the size, we know how many numbers we should display. And so within our for loop, we just kind of loop until we've hit the last number of the array. But to display the actual value, we say display the value that's pointed to by values and use the %f because it's a floating point value, and then increment a pointer to point to the next value. And we'll just keep looping until we've gone through all of our values in this way. So we can treat an array as an array, or we can use a pointer to the values of the array. Now in this case, we've got an array of character strings. And so we don't have an array of characters, but rather we have an array of character strings. And so our definition is we've got an array of pointers that's 5 elements long. And we're initializing it with a pointer to the string hello, a pointer to the string world, a pointer to the string pointers, a pointer to the string r, and a pointer to the string easy. And so they're each just pointers to the start of a character string. And so we can then loop through using a for loop each one of our 5 items in the array, passing those to printf to print them as strings. Each item in our array points to the start of a character string. Printf knows how many numbers of characters to display for each one because each string ends with the null character. So where do we use pointers to an array of character strings? Well, we're going to look at command line arguments later, and we'll see that when we type a command at the system prompt, the operating system passes that command line to our C programs. We can get to that using parameters passed to main. So we can see that we changed from int main void to 2 parameters being passed to main. The first, argc, contains a count of the number of command line characters. The second, argv, contains an array of pointers to character strings. Those are our actual command line parameters. And so if we were to pass copy file name 1, file name 2, we would see argv would have copy, and then a pointer to file name 1 and a pointer to file name 2. So in this case, we're running the command within a special environment, so I can't pass command line arguments to it, but I can still run the program. And when we do, it's going to loop through the command line, which only has the name of my program, which in this case is the file name with the .out extension. But we'll visit command line arguments in detail in a later lesson in this course. Now, pointers aren't hard. A pointer just simply is an address of something in memory. What gets challenging about pointers is that programmers can create applications where a pointer points to another pointer, and that pointer points to another pointer, and that's finally the value that we want. So this series of indirections using pointers can get confusing. In this case, we're going to create a pointer to a pointer. So we created a variable strings. It is an array of pointers to character strings, and we initialize it with hello world, pointers, r, and easy. So those are the strings that the array points to. We're then declaring a variable. Look at the double asterisk. That's a pointer to a pointer of type char. So a pointer to a pointer character string. And we're initializing it with the address of our array that has the pointers to character strings in it. We can then loop through that array using our pointer to a pointer. Let's see how we do that. And so sure enough, by taking that value, initially it's pointing to the character string hello. And so we display that and we increment the pointer, which causes it to point to the character string world. We increment that, which causes it to point to the character string pointer. And we do that through our entire loop. And so again, a pointer is just an address, but we can start pointing to yet another pointer, yet to another pointer. And so that's where pointers start to become confusing. It's just hard to keep track of what am I currently pointing to. Let's look at how we use this technique to display our command line arguments. So before we had int main with our int arg count, and then we had an array of pointers to character strings. Well, now we're just going to use a pointer to a pointer, and we're going to use that value to loop through our command line. And when we do, we've only got one command line parameter. It's the value of our program. But when you see C programs, you're going to encounter times where people have defined main in this way. And so it's using a pointer to a pointer of type char. So in this case, you can think of our array of pointers to type char. Okay, it's just pointing to an array of pointers in memory. And so getting used to the indirection is where people start saying pointers are confusing, pointers are hard. A pointer is just simply a memory address. And so we said things can get a little bit crazy. And so we can create a pointer to a value. That value can be another pointer, and it can point to a value that's another pointer. And so this is where you'll start to say, okay, I like pointers, but you can get out of hand. And so let's take a look at what we've got. And so we'll look at main first. We're declaring several different variables. First, on the far right, we're creating a variable called value. We're assigning it 1001. That should look familiar. It's not a pointer, it's just a variable. Then level 1 is a pointer to a value of type int. So it's going to have the memory address of a value, and that value is type int. Level 2 is a pointer to a pointer of a value of type int. Level 3 is a pointer to a pointer that ultimately is a value of type int. And so we can assign value, level 1, the address of value. Then we're assigning level 2 the address of the level 1 variable. It's a pointer to a pointer. Then we're assigning level 3 the address of the level 2 variable, making it a pointer to a pointer to a pointer. And so we then have a function that says, let's make some sense out of this. What's the value that's pointed to by level 3? So we've got a function that's called what is the value. And you can see it gets a pointer to a pointer to a pointer of type int. And using indirection, we can then say, here's the value that's pointed to by that pointer to a pointer to a pointer. Best way to understand this is to start to draw it out on a piece of paper. And you'll see that, okay, yes, this starts to make sense. But chasing the levels of indirection is a little bit crazy. Let's go ahead and run this. And sure enough, we ultimately point to a pointer that points to another pointer that points to a pointer that points to our value of 1001, and we see the correct result. Try not to do this in your programs. It's just too confusing for another programmer who's reading your code to follow. And so you can do it, but just because you can doesn't mean you should. Depending on who you talk to, pointers can get a bad rap. They'll say pointers are dangerous. And to some extent it's true. If you don't manage what you're doing with pointers, you can suddenly overwrite the wrong values in memory because you're pointing to the wrong location. Let's take a look at an example. In this case, we've got two character strings, one called string 1, one called string 2. First string contains the string hello world, the second one Chris James. We then declare pointers to each string. So pointer 1 and pointer 2. And so we want to find the end of string 1. This is a good exercise using pointers. We look at the value that's pointed to by the pointer, and is it null? No. Then look at the next value. Is it null? No. Look at the next value. And then we want to, once we find the end of the string, we want to append the contents of the second string to it. And so while we've assigned a value to the first pointer that's not null, keep looping. Get the next value, assign it. Is it null? Nope, keep looping. Is it null? Keep looping. When we finally find the end of that second string, which is null, our loop ends, and we're going to display the result. So what we should see is hello world with Chris James appended to it. And sure enough, we do. And so this program worked. And it only worked because we had enough space in that first array to store both strings. But here's a case where we don't. We just defined string 1 as the size of the hello world message. Now we're going to append data to it. And when we do that, we're suddenly going to overwrite the size of the buffer that the C compiler allocated for our string, giving us a buffer overflow error. So we're going to go loop through and find the end of string 1, and then we're going to start appending characters to it. When we do that, we suddenly exceed the size of the memory that the C compiler allocated for string 1, and we get an error. Let's run this. It may crash everything. And it just happened to work, which wasn't the demo I was wanting to see. It'll give us random results. And the point is, we've now got a buffer overflow error. Buffer overflow errors are familiar, or should be familiar to you as a security risk when you're creating websites. When we first started building websites, hackers would create buffer overflow errors, and the default response by the system was a lot of times just display a system prompt, and then they could get access to the server. And so we'd use buffer overflow errors to break programs. Because pointers can lead to poorly programmed code that allow a buffer overflow error, they have the reputation as being dangerous. And so when you work with pointers, you need to just be aware of the fact of where am I at in memory? Am I overwriting the wrong locations? And so because pointers can be a little confusing, particularly pointers to pointers or pointers to pointers to pointers, you can suddenly get into a situation where you're overwriting the wrong memory location, and it creates bugs that are hard to debug. And so we've learned how to create pointers to variables. It turns out that we can also work with pointers to functions. And so your question may be, why would I want to do this? And when we look at searching and sorting in a future lesson, you'll see that when we want to sort values in an ascending order or a descending order from highest to lowest, we can pass a function that says, here's the comparison that I want you to do to sort the values. I want you to sort in descending, use this function. I want you to sort in ascending, use this function. So we'll actually pass the function that we want the sort routine to use, and it will call it. And so that's passing a pointer to a function. Let's take a look at a simple example. We've got a function called 1, and it just displays a bunch of 1s. That's easy enough. We've got a function called 2, it displays a bunch of 2s. Okay, I'm still understanding that. Then we have a function that says call a function. It's getting a pointer to a function that returns a value of type void and receives no parameters, so it's of type void. Now there's some syntax that may scare you. Always start inside the parentheses. We've got a pointer. Its name is, the variable's name is function. It's pointing to a function that returns type void. In the parameter list, there is no parameters, so it's type void. You can see within the function, it just calls the function that it was passed to. And so in main, we're calling it, passing it the address of the function 2 and passing it the address of the function 1. So let's go ahead and see if this works. And sure enough, we see our 222, which our function 2 displayed, and 111, which our function 1 displayed. So our pointer to a function worked. Again, typically you won't be doing this often. You need to know you can. You will be doing it when we start looking at searching and sorting. So that's why I wanted to talk about it now. So in the previous case, we had a pointer to a function that didn't get any parameters. In this case, we're going to have a pointer to a function that does receive parameters. The first function is a function called add. It gets 2 parameters, a and b, and returns the sum of those. The second is a function called mult. It gets 2 parameters, a and b, and returns the product, or the multiplication of both. Our call a function, let's take a look at our definition now. We have a pointer to a function that returns a value of type int. Okay, that makes sense. It gets parameters. The first parameter is an int, the second parameter is an int. Okay, and then it's getting passed the values a and b that it's supposed to pass as parameters to the function. And so within call function, we just present or print the value, the result that's returned by the function that we call. So in the first case, in main, we're calling call function with the add function. And we want to add the values 1 and 3. And then we're calling it with the mult function. We want to multiply the values 2 and 4. So we're calling the same function, passing the address of a function to it. Let's go ahead and run this and see what we get. And sure enough, 1 plus 3 is 4, and 2 times 4 is 8. So everything worked. But you can see how the declarations start to become a little confusing. It will take you a few minutes to say, okay, I'm getting a pointer to a function that returns type int, and here's what its parameter types are. But quite a bit of flexibility in there. But you can see the code starts to become a little difficult to read. So how will we use functions in the programs that we're going to learn throughout the course? We're going to do a lot with pointers to character strings. We're going to build a whole string library. String to uppercase, string to lowercase, string to length, string reverse, find a substring. And we're going to do that using pointers so that you get a good understanding of pointers. We're going to create pointers to structures. So we can create a linked list or a doubly linked list or a binary tree. We're going to use pointers to functions when we do our searching and sorting. And then there's going to be times where we allocate memory dynamically as our program's running, and we'll get pointers to those. So we're going to use pointers in a myriad of ways throughout the rest of the course. So what are you going to learn next? C programs make extensive use of pointers, particularly to deal with character strings. In the next lesson, you'll learn how to build your own library of commonly used string operations. So here's one, for example, string length. It returns the number of characters in a string. So you can see that it gets passed a pointer to a character string. We then have a variable called count that we're going to use to count the number of characters. And then we're going to loop. While the value that's pointed to by the string pointer is not null, point to the next one and increment the count. And so we're just going to loop through our character string that's pointed to by the pointer until we find a null character. Then we're going to return count, which has the number of characters that we've seen. We're going to do the entire library of string operations using pointers. By the time we're done, you should be pretty comfortable with pointers.